Good afternoon, ladies and gentlemen. Welcome to Hollywood Fails in Physics. Today we're going to be doing film analysis on Kingsman: The Golden Circle, a great action film with a lot of cool special effects. Now, in particular, we're going to be looking at the diner brawl scene at the very end of the film, where we have Agent Whiskey of the Statesman facing off against the two Agent Galahads of the Kingsman, the sister agency to the Statesman. Now, we have right here in our sights the electric lasso. Electric lasso is a pretty cool weapon because it can cut through metal. We're assuming that it's using electricity, even though we don't actually see an external power source, but we do see it light up blue, which is pretty cool. So we're going to talk about the physics of it after we watch the clip, and we're going to be making a lot of assumptions here, just because there is no visible power source and they don't tell us how it works. So I'm going to be going through a little bit of the math with you, using some real world values, and we'll put all that together. Enjoy.
I think it sounds like a bright idea.
That was a pretty cool fight scene, right? I mean, it's not bad, but let's break it down a little bit. So we have our fictitious metal, right? Because it's not seen or it's not explained. So we have, let's just call it 4140 chrome moly steel. That is the average mil-spec steel used in service pistols and law enforcement pistols, things like that. Then we'll also use a power source that weighs 45.3 kilograms, which is an industrial power source that pumps out 400 volts and 105 amps of power. Using all of that together in both a power equation and an energy equation, we can get 42,000 watts for the power. And we can also, using the melting point and the specific heat capacity of the steel, get 30.3 million joules. Now, that's a lot of joules, but it's not as much as you think it is, so let's continue. If we want to find the time of how much all this stuff would take, we plug it into an equation where we take the energy and we divide it by the power output. Now that gives us 722 seconds. For everyone wondering, that is just over 12 minutes. 12 minutes to charge up and get the same relative power that in the movie it happens instantly. Now that's an interesting concept, because if it happens instantly in a power source that is, again, fictitious, we take the energy and we divide it by the time that it would take in the movie, which is roughly half a second. It is instantaneous after all. So if we divide 30.3 million joules by half a second, we get 606 million watts, or 606 megawatts, which is a lot. But just for good comparison, a power plant puts out 1,000 megawatts a day. So while this is still a significant amount of power, and it actually is, when you really think about it, there's no power source that is small enough that can fit in the handle of a bullwhip. So if we use those numbers, an average bullwhip handle multiplied by 2 just to get a basic weight, because you don't want it to be too heavy. It's got to be agile. It's a weapon. So it's 1.53 kilograms, which is a rough value. Multiplying that by 473 joules per kilogram Kelvin, which is the specific heat capacity of the metal. And we use the blue light that we see emitting from the lasso, which electricity doesn't have a color, but it does have a temperature. So that's roughly 4,700 Kelvin when you take into account the temperature of the room. So all of that together is 3.4 million joules. That's still pretty good, considering the fact that this fictitious power source doesn't weigh anything more than almost 3.5 pounds. So is it real? No. Does it really fit? Not really, but it's cool. Thanks for watching.